Look at this. Here's a video message recorded in Telegram on a Pixel 9 Pro, and here's the exact same shot but recorded through the stock camera app and sent as a video. See the difference? Same phone, same camera, same lighting, but the difference is obvious. And no, it's not just compression, the problem goes deeper. I know why this happens, and I'll even show you how you can try to fix it. My name is Kirill Rozov. You're watching Android Broadcast, a channel where I talk about how Android actually works and about mobile app development. In this video, I'll explain why your $1,500 flagship can shoot video like a budget phone. We'll figure out who's responsible for this and dig a little deeper into the root of the problem. Everything comes down to one thing. How does an app actually access the camera? Any app that wants to use the camera relies on a special API, a set of tools through which Android as the operating system provides access to camera hardware. And this API has quite a long history. Camera API/Camera1. The original Camera API, later referred to as Camera1, was the first camera interface in Android. It appeared in the very first version of Android alongside the first Android smartphone. It's extremely simple, but also very limited. It gives you only basic camera functionality. Turn the camera on, take a photo, record video, that's it. Today, it's officially deprecated. Google explicitly says, don't use it. There are newer, better alternatives, but many apps still rely on it because it's simple, predictable, and most importantly, it works even on your grandma's phone. Camera2. Later, Google introduced the Camera2 API. It arrived in Android 5.0 and was a huge step forward for developers. It finally exposed manual control over almost every camera parameter. But along with that came new problems. Camera2 is complicated for device manufacturers to implement, and every manufacturer could implement it slightly differently. On one device, everything works perfectly. On another, bugs. On a third, compatibility mode, where under the hood it simply falls back to Camera1. So you might be using the new API. But internally, the system still relies on the old implementation. Imagine having a brand new car body. Sleek, modern, powerful. But under the hood, the engine is still from a 20-year-old model. Why third-party apps shoot worse? And even when Camera2 is fully implemented, it still doesn't expose many of the features available in the stock camera app. Because things like HDR night mode multi-frame stacking are not part of Camera2. These are proprietary algorithms from the device manufacturer. They live inside the manufacturer's camera app and firmware, and only that app has access to them. Android itself simply doesn't know these capabilities exist. Google understood that the camera situation was painful for everyone. So, in 2019, they introduced CameraX.
So we built CameraX, a Jetpack support library that makes development incredibly simple.
CameraX is a library that simplifies working with the camera and solves compatibility problems across devices. It's built on top of Camera2 and handles all the messy parts for you. Google took this very seriously. They created a dedicated testing lab where more than 100 real device models are tested every day. Each phone sits in its own controlled test box with calibrated lighting and test charts. Together, this test coverage represents over 750 million active users. Remember when I mentioned that different devices behave differently? CameraX currently includes more than 30 quirks, known issues on specific devices, and automatically fixes them. For example, on some phones, when converting color spaces from YUV to RGB, a column of pixels gets shifted. On others, video and audio drift out of sync because of incorrect timestamps. CameraX fixes these issues automatically at runtime. The developer doesn't even have to think about it. But the most important feature CameraX introduced is access to manufacturer camera features from third-party apps. This mechanism is called vendor extensions. The idea is simple. The device manufacturer provides a special library that exposes advanced camera capabilities to any app. What kind of modes are available? HDR night mode, portrait mode, face, retouch, auto mode. Now it's important to understand the roles here. Google defines the standard and the interfaces. The device manufacturer must implement the extension library for their devices. Samsung, Pixel, Xiaomi, each one implements it for their own devices. But the big question is, do all manufacturers implement it, and do they implement it well? Spoiler, not always. And finally, the app developer must actually integrate these extensions into their app. Vendor extensions aren't limited to CameraX. Starting with Android 12, Google also exposed them through the Camera2 Extensions API. So even if an app doesn't want to depend on CameraX, it can still use the extensions directly through Camera2. The excuse, we don't want to add another dependency, no longer really works. There's documentation, there are guides, there are code samples. So why is everything still bad? The solution exists. So why don't Telegram, WhatsApp, and other apps use it? There are several reasons. Fragmentation vendor extensions don't work on every device. So apps need a fallback plan when they're unavailable. Old device support, many apps still support Android 6.0. And Camera2 behaves very strangely there. Formally it's available, but internally it may still be proxied through Camera1. CameraX can also behave unpredictably on such devices. So developers often choose Camera1 because it simply works everywhere. Motivation for Telegram: the camera isn't the core feature. Telegram is a messenger. The camera is just an additional feature. Why invest engineering resources into a complicated integration if users already keep using the app? And Google doesn't force migration either. No incentives, no penalties. So developers take the path of least resistance. But you can actually test this yourself. Telegram has a hidden setting. Open Settings, tap the app version several times, and the debug menu will appear. Inside, there's a switch called Enable CameraX. Turn it on, and Telegram will start using the new API instead of the old one. The result is immediately visible. The image becomes cleaner, colors are richer, dynamic range improves. But there's a trade-off. Some shooting modes may stop working, and stability is not guaranteed. Android's openness is both its greatest strength and its greatest weakness. Hundreds of manufacturers, thousands of devices, and there's simply no way to guarantee that identical hardware behaves the same everywhere. But things are slowly improving. CameraX continues to evolve, new capabilities are added, and device-specific bugs keep getting fixed. And importantly, CameraX is distributed through Jetpack, independent of Android system updates. Even if your manufacturer stopped updating your phone, camera libraries can still keep improving. By the way, you can check your device's camera capabilities right now. There's an app called Camera2 API Probe. It shows your Camera2 support level, available extensions, and other camera characteristics. Google also maintains an official list of devices that support extensions. I'll leave the links in the description. If you learned something new today, leave a like, and if you want more deep dives into how Android works internally, subscribe to the Android Broadcast Telegram channel. Leave your thoughts in the comments. See you next time.